Hello everyone, I am Piyush Wairale. Welcome back to our lecture series of Getting Data Science and Artificial Intelligence. So we are first covering the Artificial Intelligence syllabus. We already started the DBMS part also, so you can watch the DBMS videos also. So this is lecture 2 for Artificial Intelligence. In the lecture 1, we have discussed about the important terminologies which is required to understand the topic of search algorithm. Okay, and we have also seen one example, that is 15 puzzle example. Okay, so if you have not watched that video, I will recommend you to watch that video first, and then you can come back to this particular lecture. Okay, so now let's start with the lecture 2. So we'll try to revise the concept that we have discussed in the first lecture, that is basically a search problem, introduction to a search problem. Now this is 15 puzzle game, right? Now suppose AI is playing a game. So suppose AI agent is playing a game. Okay. So what is AI agent? So we all this thing we have discussed in the last lecture. So this is basically an initial state. Okay. This is my final state. Final state, or I can say goal state, right? So this is my initial state and this is my final state. So I want to convert this particular configuration of this puzzle into this, right? So this is how we play the 15th puzzle game. Suppose AI is playing this particular game. So he should know how to play this game, right? So what are the possible actions that he can take in this particular configuration? And then what is his initial state and what is the final state? Okay. So how to play this game, what is initial state and what is final state? These few things that AI should know, right? We have discussed this example in detail. We can move this empty space like on the left hand side, on the right hand side, up and down like this. So here we have four different state, right? Based on each action we made, whether on right or left, we have four different state. Okay. So whatever the action we will take on one state, it will give us a new state, right? This is basically a new state. So each one will be a new state. Okay. So here also, if we consider 15 puzzle game, so if I move this empty space here, so I can also have four choices here. I can also perform four action here. I can move this up, right, left and right. Okay. So then I will have three, four choices. Same thing for here also, in this state also. Same for here also, right? So similarly, if you consider, it will go like this continuously, right? So we can consider this as search space, right? So all the possible combination of a configuration is basically a search space, right? So we have also discussed that we can convert this basically a search space into a state space. So state space means what? We are convert we are considering this each state as a node. What are the action you will take? That is basically edges, right? So I can convert this basically a search space into a state space, like a graphical representation of this particular configuration, like this, right? So here I have four choices. I can go in the fourth way. Then I can again I can go in the more ways, right? So it will keep happening like this, right? These are a different state I can perform. Right? So we have discussed all those things in the previous video. You can watch it. Now, this is important key terminologies. Okay, so we have discussed this in detail in the lecture. So let us go through it. Okay, so what is search space? The state of all possible state or configuration that can be explored in the problem. So that's what we have seen in the previous slides. Now, what is state? A particular configuration or situation in the search space. Okay, so if we consider this example, so each the configuration is basically a state. Okay, now, what is initial state? The starting point from which search algorithm begins. What is goal state? Desired state, right? That algorithm is trying to reach. What is operator or actions? Actions that can be applied to a particular state to generate the other state, right? So, in the previous example, I can move either the empty style on the left, right, up, down, right? So, that is basically action, right? Now, what is state space? So, state space can you visualize as a directed graph with states represent as nodes and action represent arrow between them, right? So, what we have discussed is like same thing, that is state space. This is basically a state and this is basically action. So, arrow represent action and each node represent the state, right? Yeah. So, what is path? The sequence of states that connected by operator from initial state to goal state. We have seen that. Now, what is path cost? Numeric cost associated with a given graph, right? So, suppose, for example, okay, we have this example, right? I want to reach this particular node, right? This is my final goal. This is my initial goal, right? I can go in this way, right? This is my particular path, but I can go like this way also, right? So we need to choose a path which will take a less cost. Less cost in the sense less resources, or which is the shortest path, right? So that is what the path cost is, a numerical cost associated with a given path. And the solution we all know, specific path from initial state to a goal state, that's basically a solution. But also we have optimal solution, right? So what is optimal solution? The specific path must be shortest path, right? If that path is shortest path, then we can say we have got the optimal solution, right? So these are the different terminologies that we have discussed in the last lecture. So I hope you understand this. So if you have any doubt, you can watch the previous lecture. Okay. Okay. So let us discuss about the uninformed search now. Okay. So if you see the next syllabus, in that search topic, we have three search strategies. That is informed search, right? Then we have uninformed. Then we have adversarial, right? Search. So we'll discuss these three strategies one by one. Let us start with uninformed search strategies. So as name suggests, it's uninformed, right? So basically it's algorithm used to solve the problem where the solution is not known in advance, right? So these algorithms are also known as blind search algorithm. So please remember this that uninformed search is also, uninformed search is also known as blind search, right? So please remember this because they operate without any specific knowledge about the problem domain, right? So suppose, for example, let us take same example, okay, about the graph. If we have graph like this, okay, this is my say suppose initial state and this is suppose my final state. Okay, so I want to go from I to F, right? So in the case of uninformed search, I only know this is my initial state and this is my final state. I don't have any other information about the specific domain or specific problem, right? I don't have any other information about the given problem, right? So I don't know how far it is from this particular node or this particular node, how far it is from starting point. I don't have any information about it. I only know, okay, this is my starting point, this is my goal, right? So what it will do, what AI agent will do, first it will check, okay, whether it is my goal. So whether it is my desired node or desired goal, if yes, it will stick, right? So we have to explore that, right? So in this way, AI agent will traverse in the graph and will try to check whether okay, this particular is node is my goal state or not. Whether this particular node is my goal state or not. So it will try to explore all the nodes until it finds that okay, so this particular node is my required goal, right? So we have only knowledge about the initial state and final state. That's it. We don't have any other knowledge, right, about the specific domain or about the specific problem, right? So that's what the uninformed search is, right? So unlike informed search algorithm, which use domain-specific information, so in informed search we have some other information also. Like for example, okay, if I go by this route, I will take this much time to reach here, or if I go by this particular path, so distance between F and this particular node is that much. We have some kind of information, right? Either in the form of distance, or you can say coordinates, or it can be anything, right? So, but we have some specific information so that it will help us to reach this particular goal, right? But in the case of uninformed search, like we don't have any prior knowledge about the problem, right? So that's what uninformed search is. Okay, what we will discuss this in detail one by one. Now, uninformed search algorithm. So there are various type of uninformed search algorithms, right? So each with its own strategy for exploring the search space, right? So there are some commonly used ones are first one is breadth first search, right? So in this algorithm, what happens? AI can explore all the nodes at a particular given depth before moving to the next level. Okay. Say for example, this is my tree. Okay. Let us take sample tree here. Okay. Like this. I have this particular tree. Okay. So what breadth first search algorithm will do? It will try to explore the nodes level wise. Level wise means breadth wise. So this is level 0, this is level 1, right? This is I can say level 2, this is level 3, and this is level 4. Okay. So what breadth first search will do, it will try to explore all the nodes at a particular given depth before moving to a next level. So first it will try to explore this, then this, then this, and this. Like this, it will go breadth wise of the graph, right? Then this, and then this. So this is a particular example of queue. So that is queue. That is first in, first out. Okay. So what is first in, first out? What is queue data structure? We are going to discuss this in detail. Okay. So don't worry about it. So the next type is depth first search. Okay. So same example in DFS, what we do, we try to explore the nodes as far as possible along a branch before backtracking. Suppose I want to explore this particular node. Okay. This M. Okay. Let me Yeah, suppose I want to explore this particular M. So this is my goal state. Okay, this is my goal state. But I'm starting from here. This is suppose this is my initial state. Now I'm going in this path. I can go this direction or this direction. Or suppose if I go in this direction, okay. So I will try to match whether it's my required goal or not, right? So it is not, right? So then we have again two nodes to explore. So I will go in depth. I will go like this. Suppose I will explore this particular node first, then I can go for this or this. If I go for this, I don't have any other nodes to explore, right? So I will backtrack my particular path in this way. So I will go for next node, right? So that is basically this one. So again, I will try to do, okay, whether it's required goal or not. Then in this way, we'll try to explore as far as possible, right? In a particular path only. Unless we found, okay, we don't have any other node to explore, so then we'll backtrack, okay? So from that, we can explore any other node, no. From that, we can explore any other node, no. From this, we can explore, no. From this, no. But from this, yes, I can go for this particular node. Then I will go in this direction like this, okay? So there is one thing. So this is how we do in DFS. This is how graph traversal work in DFS. So basically, it uses stack data structure. So that is last in, first out. So we are going to discuss this in detail. We are focusing on this two algorithm more than other algorithms. Okay, I think this is important exam point of view because we don't know like what questions they will ask. Two are famous algorithm, right? DFS and BFS. So we'll try to explore this in detail. But in the case of breadth first search, it will go breadth wise like this. But in the case of depth first search, it will take one path. It will go as far as possible unless they find any other node. Unless they find any other node, or if they don't have any other node to explore, then they will backtrack to a nearest node, right? So that's what DFS will do. So we'll try to explain with the help of example also. Don't worry. The next is uniform cost search, right? So what it will do, basically it will consider the cost of a particular path when expanding the node. Okay. So we'll discuss this. Don't worry. Now what is depth limited search is? So in the case of DFS, as we have discussed, we'll go as far as possible in a particular path, right? But there is a possibility there is a possibility that I will end up with a particular loop. Okay. So for example, I have a loop like this, right? Right, so there is a possibility I will end up with a particular loop, right? So what depth limited search will do, it will limit the depth of a search, okay? So it will limit the depth of a search to prevent infinite loop in DFS. Let us consider we have 1 million, let us consider we have thousands of nodes to explore, right? In that case, it will take too much time to go in the particular depth and then again backtracking, right? To the nearest unexplored node. So that's why we use this particular algorithm, that is depth limited search. Okay, then next we have iterative deepening depth first search. So this is basically a combination of BFS and DFS. So you can say it is a combination of these two, BFS and DFS. So what it will do, it will gradually increase the depth in each iteration. Okay, so we'll discuss this also. Don't worry. So these are few types of algorithm that we use in uninformed search algorithms, right? We'll try to explain this one. We'll try to explore this one by one. Okay. But for this course, we'll be focusing more on these two uh, algorithm. Okay. Rest we will just have a overview of it, right? We'll see based on the time. If we get, we'll also explore more about these three algorithms. Okay. Now there are few other terminologies like for completeness, right? So what is completeness here? The search algorithm is complete if it guarantees finding solution if one exists, right? So completeness means what? If you are using any algorithm, so if it guarantees that it will give me a particular solution, If possible, then we can say it is completeness, right? Now, what is optimality? An optimal search algorithm finds the shortest path to a goal, right? So that's what we aim for, optimality, right? The shortest path to a goal, right? Sometimes we just require a particular solution path, right? May not be optimal. That is also fine in some cases, but right. So yeah, you can take that. So when to use uninformed search, right? Uninformed search algorithms are suitable for small to moderately sized search. As I explained in previous lecture, suppose if we have 10,000 or millions of state pages, then in that case it will be very time consuming, right? We use this algorithm where domain specific knowledge is limited or unavailable, right? And for small to moderate size search also. So that's the case. So we use this uninformed search when we have limited knowledge about a particular problem, or the search size is search sample space is less. Okay, so that's when we use the uninformed search. So what are the limitation of uninformed search? So uninformed search algorithms may be inefficient for large search spaces. So that's what I discussed. They don't take advantage of domain-specific information, which can lead to unnecessary exploration, right? Since we don't have any information about a specific domain or a problem, so we unnecessarily will go to a particular depth and we have to track back like this thing. So it is time consuming, right? So these are the few limitations of uninformed search. Don't worry, we'll try to explain each and every algorithm in detail in upcoming videos. Okay. Now, what is informed search? So, informed search algorithm, in contrast with uninformed search, use heuristic or domain-specific knowledge to make informed decision during the search process. Right. So, heuristic means we have some information, like we have some information in the form of say distance or coordinate, right? So, while we can predict something about a particular problem, right? So then that's what we can say heuristic, right? Now, this algorithm prioritizes exploring paths that are more likely to lead to a particular solution, making them more efficient in many problem-solving scenarios. So, in simple way, informed search is used whenever we have a domain-specific knowledge, so that we can take some decisions during the search process. So that's what informed search is. So there are several types of informed search algorithms. So let us discuss one by one. So first one is greedy best first search, and other is A star search. Okay. So we'll discuss this in detail as we move on to our lecture series. Now, same terminologies, completeness and optimality. The completeness and optimality of informed search algorithm depends on the quality of heuristic use. The more information you have about a particular problem, the quality of information you have about a particular problem, better will be the solution, right? So that's what it says. When to inform search, the informed algorithm ideal for solving with large and complex search where it is important, where domain specific knowledge can be leveraged. Okay. If we have domain specific knowledge or some information about a particular problem, in that case we can use informed search strategies. Okay. Now they are particularly effective when you have good heuristic that accurately estimate the cost of each of the good. Right? That is also correct. Now what are the limitations of this informed search? The performance of informed algorithms heavily depends on the quality of heuristic, right? If we have selecting wrong parameters, right, then in that case uh, it will lead to insufficient searches, right? So that's what it tells. Now, informed search algorithms may not always be suitable for problems where heuristic information is not readily available. So, as this informed search is suitable only for this informed search is suitable more for when we have some information about a particular problem, right? So that's what it says. So in short, just remember two important things. Uninformed search, basically we don't, it means basically we don't have any information about a particular domain or problem. Informed search, in the case of informed search, we have some information about a particular domain. We have some parameters which we can use which we can use to solve our particular problem, right? So that's what uninformed search is. Then we have something called adversarial search. Okay. So up till now we have discussed like what is informed, what is problem, or we have discussed example where only one player is there. For example, in the case of puzzle, only one player is playing, right? We have only one player for playing this particular game. But what if we are playing say tic-tac-toe? Okay, tic-tac-toe. Or for example, are playing chess. So if you want to build an algorithm that can play chess against human, so in that case we can use adversarial search because our actions will depend upon the opponent we have, right? So based on his action, we are going to take our actions, right? So that is basically adversarial searches. So it is a fundamental concept of AI that deals with decision making in competitive environments. Yes. So here we can see tic-tac-toe, chess. These all are competitive environment, right? So we are playing this against a particular person or an entity, right? So this basically search is widely used in games and compared to scenarios where AI agent must make optimal moves while considering the actions of an opponent, right? So this is important thing. So in this case, our actions depend on the actions of our opponent. But in the case of first to search, we are simply just going to a particular path because we know, okay, this is my initial state and where I have to go. That is my final state. So no one is playing against us. Our next step, our actions does not get influenced by any other actions or opponents, right? So that's what informed and uninformed search is. But here in the case of adversarial search, if we have some competitive environments, then in that case we have to use adversarial search. I hope you understand this particular search strategies. So just remember this keyword, competitive environment and considering the actions of an opponent. Okay, these two keywords are important. And in the case of informed and uninformed search, as name suggests, yeah, that you can easily remember from that, right? So there are different search algorithms also. So first one is minimax, then we have depth limited minimax, and we have something called alpha beta pruning. So we'll discuss this one by one in the upcoming. So that's all from this particular lecture. So yeah, that's it from my side. If you have any question, you can comment below. But in the next video, we are going to discuss about BFS and DFS. Okay. Then we'll move on to informed search and then adversarial search. Right. So that's it from this particular video. We'll discuss this BFS and DFS in next video. Okay. Thank you.